Good morning, everybody. Welcome to today's webinar on PyTecplot, loading 2D structured data with our Python API. I see some familiar names on the webinar today, so welcome back. Let's get right into this. So our presenters today, myself, Scott Fowler, Tecplot Product Manager. I've been with Tecplot since 1999. Most of that time as a developer, so I've got some good technical knowledge and the last few years taken over as the product manager. I'm joined with Devin Simpson. She's going to be online to answer questions. So if you have any questions during the webinar, type them in the question answer pane. Devin was really the project lead for the PyTecplot project. So this API that you all get to enjoy is largely due to the direction that she provided the team and the developers. So again, we do ask you to participate today. We do have a question answer pane in GoToWebinar, so please go ahead and use that. This webinar will be recorded, so if you need to tune out for any reason, you can get a recording. That'll be available a few days afterwards, available on our website at the link that you see there. So just to serve as a reminder for those of you who may be new to Tecplot, we were founded in 1981 by a couple of Boeing engineers who were writing CFD codes, and they decided to start their own company and quickly realized that they needed a way to visualize the results. So they hired a developer who's still at Tecplot today to create a visualization tool for CFD data. And that's what Tecplot 360 is today. We're really known as being one of the most complete desktop solutions for CFD data with our integrated 2D, XY, and 3D plotting. You see beautiful 3D plots like this, but when it comes down to it, engineering decisions are often made with line plots. So we have a good toolkit for that. And we're really dedicated to saving engineers time and really CFD engineers by new file format. So we have our sizzle file format, which loads less data off disk. The less data you have to load off disk, the faster you can get your work done, the less RAM you have to use while doing your post-processing. We have Tecplot Chorus. This is a tool that's bundled with Tecplot 360 and is active as long as you have active maintenance. This helps you understand design of experiments or ensembles of data if you're in the aerodynamic space or doing outer mold line preliminary design. It can really help with aero databases. So a pretty great tool here that you can use. And then automation, and that's really what we're going to be talking about today, is how to use automation to get your work done faster. Our Python API has really allowed people to do advanced analysis as well as load file formats that aren't necessarily suited to Tecplot 360, which is something that we'll show today. All right, so let's just jump right in. What's our agenda? So we'll give a brief overview of what PyTecplot is for some of you who may not have used the Python API before. I'll give you a brief overview to how Tecplot thinks about 2D structured data. So in this webinar, we're going to be loading data out of a CSV file, which looks like a nice regular matrix, an N by M matrix, and that's very well suited for 2D structured data. I'll show you how to use PyTecplot to create a 2D structured data set, and then after we have that understanding, we'll move on to loading data out of a couple of CSV files that Tecplot can load directly, but not exactly in the most fluid manner. So using PyTecplot is a great way to get this data in. And then we'll finish it off with additional resources and questions and answers. So again, please do go ahead and ask questions as we go. All right, so let's jump into the demo portion, and just a quick introduction to PyTecplot. So PyTecplot is our Python API. You do have to install it separately from Tecplot 360. So the Python API utilizes the Tecplot 360 itself and the Tecplot 360 engine, the C-based engine, which is very fast to operate. When you install Tecplot 360, if you also want PyTecplot, you have to make sure that you have a 64-bit version of Python installed. We recommend Python 3. Remember, Python 2 has been end-of-lifed. So if you're using Python 2, please do your best to upgrade to Python 3 as quickly as you can. We will be dropping support for Python 2 in the near future. So the Python installation, there's slightly different installation steps per operating system, but for the most part, you should just be able to type pip install PyTecplot, and then you'll have access to the Python API. So in today's webinar, we're going to be using Jupyter Notebooks. If you're not familiar with Jupyter Notebooks, this is a way of running Python in the browser. I find it very convenient for a lot of my work, and we're also going to be using our Python API connected to a live running Tecplot 360, and we'll show that in just a second. So what you're looking at here is a Jupyter Notebook. So let's start with how does Tecplot think about data and how does it organize data, because this is going to help you understand the Python APIs and kind of the hierarchy of our API calls. So first, Tecplot thinks of, has an object called a frame. That's what we see here that I'm resizing. Within the frame, you have a data set, and within a data set, you can have multiple zones and multiple variables. So if I go into the data set information dialog, you can see I have one data set, which came from a PLT file, and I have two zones and multiple variables. So each zone has the same set of variables as is indicated in this image here, and then each zone can have a different set of values. So in this case, I have a fluid volume and a wing surface, and that fluid volume has many more points than the wing surface. It's also a different zone type, whereas here we have FE brick for the volume, FE quad for the surface. So if you were going to bring data in from an arbitrary source, let's say you had a single column of data and you wanted to draw a line plot, Tecplot does require two variables. You have your independent variable and your dependent variable. So in this case, if we were to import just a single column of data, we'd have to manufacture a independent variable to make that line plot. If you have multiple columns of data, which is kind of like what you have here, you would bring this in as a single zone with multiple variables if each one of these columns does have the same number of entries. So in this case, you could represent this as a line plot if there's no other structure to the data other than the order of the points, or if there is a structure like you have on these grids in a CFD solution, then it can be represented as a 2D or 3D object. Okay, so let's get into actually using the Python API, and we'll actually run some code here. So when you're using PyTecplot, you first need to import the Tecplot module, and we like using a little shorthand notation for the module, so we say import Tecplot as TP. Just execute that line of code, and from then on I can just use TP as a way of prefacing all of my calls that go into PyTecplot. Now this first line of code here, TP session connect, that's going to tell our Python API to connect to the live running version of Tecplot 360. And I have to tell Tecplot 360 to listen to those connections through the scripting menu, PyTecplot connections, and then I just make sure that this is checked. If you do have multiple Tecplot 360s running, you can do that by modifying port numbers. We're not going to get into a lot of that detail today, but just know that that's there. Default port is 7600. Okay, so we'll connect to a live running 360. We're going to clear out this layout, and then we're just going to load the same data set back in. So if we execute this, you can now see that we've modified this layout slightly. Let's move this frame back up so we can see the data and the data set info dialog at the same time. You can see that I've captured a handle to the data set. We can hold on to data as handles. And here, if we remember this hierarchy of data, frame, data set, zones, and variables, we're going to also ask for the data set directly from the frame so we can follow that hierarchy. So I'm asking the frame for the data set, and then I'm asking the data set to print some information about itself. So you can see that it has a data set title, which is seen over here on the dataset page. And you can see that it also tells you which zones you have and the set of variables. Now, one of the things that you can do is you can iterate over zones, so we can get access to each one of the zones in my data set. We have some neat capabilities here. You can iterate over all the zones, or you could iterate over a subset of the zones using a wildcard search, which is pretty handy. One thing to note that I have here is the zones API returns what's called a Python generator, which can really only be iterated over once. So if you do need to use that set of zones multiple times, it can be handy to cast it to a list, and that way you can retain that one list of zones for multiple uses. So let's just execute this code. So we can see that we're iterating over all the zones, and we get the fluid volume and the wing volume. We get some information, or sorry, the wing surface. We get some information about each one of these zones when we print the zone object. Points, cells, and number of points per cell. And then using the wildcard search, we only have one zone that has the name wing in it, and we get that result. Now, iterating over variables, same idea. So here we've iterated over all the variables and got the full list, or here we've iterated over the variables that just start with the word momentum. So those wildcard searches can be pretty handy. Okay, here's where PyTecplot gets really interesting, is because you can not only get information about what data you have loaded, but you can actually get access to the raw data. So there are a number of different ways to access the raw data. You can access by name, by index, and by object. So we're just going to demonstrate each one of these. So here I'm asking for the temperature values of the wing surface, and we'll just execute this line of code, and let's just confirm this in the dataset information dialog. So we'll find the temperature variable, and you can see that this told me that I have 1,453 points for the temperature variable, and I have a min-max of 312 and 464, and that's the same thing that I see here. One thing to note here is that this call, dataset.zone.values, this returns a what PyTecplot calls an array. It's a fairly generic term, but one important thing to note here is that this is simply a handle into the data that's stored within the Tecplot engine. So we haven't actually pulled any data out into Python space, so we haven't increased the amount of RAM being used other than holding on to a handle. So this is just a little handle into the data that is still residing in the Tecplot engine. And a little further down here, we'll show you how to extract that information into Python space and then do modifications to it. All right, so this is accessing the data by name. To access the data by index, you can use ordinal values here, and these are zero-based values. So we're going to use the value of 1 to access our second zone, and we're going to use the value of 10 to access our 11th variable. And we can see that we get the same values here. And then again by object, so we can hold on to handles for each one of these. So here I'm asking for a handle to the zone, and then I'm going to ask for a handle to the variable, and then I can combine those and get the same information. Okay, and then finally, we can also reverse this. We can ask for the information variable first. So you can see I've got the same 2 handles as before, but I'm reversing this call. So I'm from the variable, I'm asking for the values of the zone associated with it, or from the zone, I'm asking for the values with the variable associated with it. And this is going to give the same information because this is a zone variable pair. So in both of these cases, I'm getting the temperature values for the wing surface zone. So you have a lot of flexibility here. Accessing things by name is really great because when you load data into Tecplot, sometimes you have a different data set that might have slightly different set of zones. So one thing we've seen with, say, people who are using the Converge CFD code, you have regions that can come and go throughout the simulation, or disconnect regions. So you have a spray variable that might be, or a spray zone that might be in the 10th zone number at the first time step, but the 12th slot at a later time step. So using name-based system, and wildcards can be really handy. Okay, data values can be modified as well. So this is where we start talking about pulling data out into Python space, and then we can push that data back into Tecplot space. So let's change the contour coloring here. So we're going to color by temperature, and we'll just add a few more contour levels so we can see this plot update as we make this change. So here again, just like we did before, we're going to get the set of temperature values, and then this notation, this bracket notation at the end, is going to pull the data out. It's going to actually create a list from the array that Tecplot provided us. So this is actually pulling data out into Python space. And if you have NumPy installed, I highly recommend using NumPy. Tecplot will actually pull this out as a NumPy array. NumPy gives you all sorts of mathematical capabilities that you don't have with just base Python. And we'll show using some of the NumPy functions in the further examples. So this is pulling the data out into Python space, and then we're going to convert the temperature values from centigrade to Fahrenheit, and then we're going to push those values back into Tecplot. So we're actually going to modify the values for this wing surface. So let's just execute this. So you can see that the values on the plot changed, the coloring on the plot changed, and you can see that the min and max values in the dataset information dialog changed. So some neat capability here with being able to pull data out using the bracket notation and then putting data back in using the bracket notation. Okay, so that's a brief tour of the data access functions within PyTecplot. And that's what we're going to be focused on today is data creation, data access. Okay, so we'll just clear out this layout, and let's talk about 2D structured data. So if you think about, again, a matrix or a spreadsheet, you know, a spreadsheet or a matrix is going to be dimensioned n by m. Here in a 2D structured data set, Tecplot uses the terminology I by j. So here we have a 3 by 3 structured grid, I increasing left to right, and j increasing bottom to top. Now this data is logically 2 dimensions, but Tecplot actually stores the information in a 1D array. So it's pretty important to understand how to translate from the 2-dimensional space into a 1-dimensional space, and that can be done using this formula, and we'll go down to this plot as well to help describe this. So the node number is going to be defined by a formula. So the I dimension is what changes the fastest. So in the simplified 2D case, it's going to be I plus j times I max. So let's look down at this case down below here. So we have an I max of 3. So 1, 2, 3 here. So this is our 1, 1. So this is I of 1, j of 1, I of 2, j of 1, I of 3, j of 1, so on and so forth. So if we want to find out the node number for this location, we're going to use 0-based I and j values, and we have an I max of 3. So for this, the 0-based I and j values are 1, 1. And if you plug that into the formula here, you're going to end up with a node number of 4. So you can then take a 2D array and convert it to a 1D array, which Tecplot needs. You can see that we also have the 3D case here as well. So important to know that if you do want to do a 3D case, you have that formula available to you as well. And I listed this 2 times here. This is the formula that you would plug right into the specify equations dialog if you wanted to show node numbers right within Tecplot 360. Okay, so our goal here in this set of code is to actually create this structured grid. And so one of the important things to note here is a structured grid doesn't have to be rectangular like we presented up here. A structured grid only defines the way that each node is connected to each other node. So the position of each node is going to be defined by your X and Y variables. And then the values at each node, you can have, again, n values at each node. So in this case, we're going to be adding a contouring variable, and we're also going to be adding a node number so we can plot this information. So again, let's import the modules that we're going to need. So here we're going to use the math module, the NumPy module, and the Tecplot module. So let's just create our arrays of data first. So we need to create arrays for X, Y, our contouring variable, and our nodes. And so the way that we're going to do this is we're going to loop over the I and J dimension. And the order of these for loops doesn't matter because we have our formula that we're using here to compute the proper node number based on I and J. So we could do these loops in either direction. If you weren't using this formula, then you have to be more careful about how you have those for loops arranged. Okay, so we're going to compute a radius and a theta, and then we're going to convert those into the Cartesian coordinate space. We'll just add a contouring variable, and we're going to have our array filled with the node number. So if we execute this, we can see that we end up with our X array here has 12 values, which is what we would expect because we do have 12 points in this structured grid. And you can see that the values start with a value of 1, and then 2, and then 3 for X, and then you can see that they shift over slightly to the left as we sweep through that arc. And so these are the values that we would expect. Okay, so how do we, now that we have the data that we want to use to create this structured grid, how do we actually do it in Tecplot? So again, let's connect to the live running Tecplot 360, and we're going to create a new data set. So if you remember that hierarchy, frame, data set, and then zones and variables, we're going to, in this frame, we're going to create a new data set that has 4 variables. And then we're going to add an ordered zone, and we can give it any name we want. I'm going to give it a somewhat meaningful name, 2D structured zone. And then I'm going to tell Tecplot that I want this to be dimensioned by I and J. Again, if you did have a 3D data set, you could add a Kmax here as well. It's going to default to 1, so we don't have to add that information. Okay, and again, you can see that when I created the data set, I held on to a handle. Then I used the handle of that data set to add the zone, and I'm holding on to my zone handle. Just like we did on the previous tab here, we're going to add data back into Tecplot. So here we're getting the values for X associated with that zone, and we're going to stuff that X vals array into Tecplot using this bracket notation. And we'll do that for all 4 of our variables. And then we're going to tell Tecplot to switch to the 2D plot type. We'll just execute that. You can see now I have my data right here. So I'll just right click. We can show the grid, show the contour, and then let's show our labels. So again, you can see that we have our I and J dimension, just like in the image here. And then we can show our variable values, show the contouring variable, and show the node numbers. So you can see we've got 0 base node numbers here. All right, so pretty darn simple to add a new zone and some data into Tecplot. Well, typically you're not just creating data. You've usually collected data and it's sitting on disk. So we're going to let's go into a real world problem here. We're going to talk about what we call the Seattle slope problem. So in this case, we have some data that has been collected of an area of Seattle called West Seattle. Let me just show you on Google Maps to give you a little bit more of a view. So if we zoom out a bit here, we've got Washington State, Tecplot located down here in Bellevue. If we zoom into the Puget Sound near Seattle, we have this area here called West Seattle. We have some very steep ridge lines here, some steep slopes that are prone to landslide, and certainly due to the copious amounts of rain we get here, the land gets quite soft. So using some information that was collected, we have, in this case, we're going to have a couple of CSV files that give us elevation information, and then also a value that has been created called factor of safety. So this is effectively the risk of landslide in the West Seattle area. And our goal here is to create a plot that looks like this. So on the left, we have our elevation data, and on the right, we have our factor of safety information. And you can see here, we've included a geo-referenced image behind the scene, and we've certainly altered the contour coloring a bit. But step number one is figuring out how do we get this data into Tecplot. So let me show you what we're dealing with on disk. So on disk, we have a couple of CSV files. We have West Seattle elevation CSV and West Seattle factor of safety CSV. So these are the files that we're going to try to load today. And we'll just look at what one of these two files looks like. So let's look at the elevation data. So this is a big spreadsheet, lots of rows, lots of columns. If we scroll all the way down to the bottom here, we can see that we start getting some data values out in the corners. You know, here we're out in the Puget Sound, so elevation is 0, which makes sense. Each one of these rows and columns represents a point in XY space, and this data was collected at 20-meter intervals. So this is going to be effectively the top left of our plot, and then column B is going to be 20 meters over in real space. Row 2 is going to be 20 meters down in real space. So this is kind of a perfect N by M grid, or in Tecplot parlance, an IJ ordered data set. So let's go ahead and try to load this with PyTecplot. We won't try, we actually do or do not, there is no try. Okay, so let's import the necessary modules. So here we're going to use Python's CSV module to load the data out of the CSV file. We're going to use NumPy to help us organize our arrays, and then of course we're going to use PyTecplot. So the first thing we'll do is we'll load this data out of the CSV files. So these two blocks of code here, this first block and second block, are effectively the same. They're opening each one of these CSV files, and it's going to put the data into an N by M matrix. So we'll just execute this, and then we'll have the elevation data. We'll have, this will be the number of rows in this, will be the number of rows that I have in my CSV file, and the number of columns for each row will be the number of columns in the CSV file. So your perfect N by M. And then we do a little sanity check here to make sure that our elevation data and our factor of safety data are the same size. Okay, because this data set doesn't actually supply XY variables, we have to define those ourselves. And so we're going to define that based on the number of rows and number of columns, and we're going to apply a 20-meter resolution to that. So we're going to compute our X max and Y max based on the number of columns, which is our I max, and number of rows, which is our J max. And then we're going to use NumPy. There's a function called linspace, which is going to evenly distribute values across a range. And this is going to define our X and Y values. And then we are going to call another NumPy function called meshGrid. So this is actually going to then extrude those X, Y values in the I and J dimensions. So we have a grid of data. This is going to create two-dimensional arrays, and remember Tecplot needs 1D arrays, and so we're gonna resolve that in a function call a little later. Okay, so now we have our X and Y values. Let me just insert a cell above here, and I'll just show you the X values. So you can see that each row of X values is the same, and then each set of Y values are going to increment as we go up. So each row of Y values is going to be the same as we go along. Let's just delete this cell. Okay, so now we're going to connect to Tecplot, and we're going to do pretty much just like we did on the other slide. We're going to create the data set with the 4 variables that we care about, X, Y, elevation, and factor of safety. We're going to tell it the zone name and the dimensions, and then we'll just add our data. Now remember, each one of these arrays are 2-dimensional arrays at this point, so we're going to use a NumPy function called flatten. This is going to flatten them out into a 1D array. So let's just execute that, and now we have our data here in Tecplot. Let's open up the dataset information dialog. You can see that we have West Seattle, the number of columns, the number of rows, so this will match what we had in our CSV file. If I right-click, I can do the elevation, and if we look back over here at Google Maps, you can see this is upside down. Well, the I and J dimensions start down here at the bottom corner, and so we'll just reverse the axis direction here. Then we have a result that looks a lot like West Seattle and a lot like the elevation profile. Okay, to get to the final result here, one of the really great things about PyTecplot is you don't need to do all of the style modifications in code. Because we have a GUI associated with Tecplot 360, you can do all of the style modifications using the GUI and save a style sheet. So a style sheet is a style that's going to be associated with a specific data set and a specific frame. So here I've saved off a style sheet to style my data for the elevation, and we'll just execute this. And you can see that I now have my nice elevation plot using the same the data that was already loaded. And we want to add another frame. We're going to name that frame factor of safety and then apply another style sheet, and then we'll fit both frames to the workspace. So let's just execute that, and now I have the result that I'm looking for. So I hope this has given you a good tour of the Tecplot 360 or the PyTecplot API that comes with Tecplot 360 and how you can actually utilize it to load data that you may not have thought Tecplot to be ideal for loading. I do know that we have a lot of users who are loading data out of spreadsheets, out of Excel, out of just plain text files, and having these tools in your toolbox are going to be a great way to load data in and create beautiful plots and communicate your results. Okay, with that, let's go back into the PowerPoint slide, and we'll also open it up for questions at this time. There are a couple of questions that I wanted to address to start with, and we have some that came in from registrants. So as you're thinking of questions, I'll go through some questions that have already come in. So can Tecplot 360 load CSV or Excel data directly? Well, the answer is yes. We have a number of loaders available that can load data out of those file types. We have our general text loader, which is quite flexible loader for data that is in just plain text files. That it may be CSV, it may have a header row that you want to skip, etc. So that can be a handy loader. The text spreadsheet loader is really our loader for loading CSV data. We do have an Excel loader. It is unfortunately limited to Windows only and Excel 2003 and earlier, but if you have XLS files, you can use that loader. And then we also have an Excel add-in, which is a plugin to Microsoft Excel. And for this Seattle slope data, the Excel add-in is the best option for this type of data, but it does require modification. You have to add a header row and a header column to the data, and then you have to click a button in Excel, so it can't be automated, and that's why PyTecplot is really powerful here. So we showed PyTecplot running connected to Tecplot 360. Can it be run in batch? Well, yes, it can. So if you write your script without the TP session connect, PyTecplot is going to run in batch. It's going to utilize the Tecplot 360 engine for its data processing and data loading. Just make sure that you produce output from that script, like an image or a data file or a movie file. Otherwise, when that script exits, you're not going to have a result. Can PyTecplot make a 3D scatter plot? Well, yes, any plot that you can make in Tecplot 360, you can make with PyTecplot because it does use the same engine. And one of the things to note here is, if you're not sure how to make a certain plot in PyTecplot, the great thing is the Tecplot 360 user interface has a record option. So you can record the calls that you're doing and get a good start for creating scripts to get specific styles. So the styles that I applied via those style sheets with the Seattle slope data, I could have recorded a Python script and executed each of the Python calls. But in that case, I just found it easier to apply a style sheet, fewer lines of code that you have to maintain. Can you compute a time average? We've had a number of people ask this over the last couple of months, and the answer is yes. We do have a GitHub site, so if you just search for Tecplot GitHub, you'll see a number of Python scripts that we've written that are available there. They serve as great examples for you, and also have some advanced analysis capabilities. So we do have some Python modules up there that can be quite handy for you for computing statistics, doing time average, things of that nature. Can you automatically probe over time? Yes, this is again one of those Python modules that we've made available up on our GitHub site. So again, take a look at that, and you'll see some good resources up there. And then, can you achieve high quality videos or generating plots? Again, the answer is yes. Because we are using the same engine that Tecplot 360 uses, all of your images are going to be of the same quality that you would get directly out of the user interface. Okay, well, that does it for today. Appreciate your attention. If you want to learn more about PyTecplot, just do a Google search for the term PyTecplot. You can go to our website directly here, but if you just do a Google search for PyTecplot and Tecplot GitHub, you'll find really great resources. This webinar is going to be available on our website in a couple of days, and it will be available for review. The scripts that we went through today, we will bundle those up along with the example data, so you'll have those as a resource as well. If you do need to contact support, we do have support in North America. We're available 6:30 a.m. to 5 p.m. Pacific time at support@tecplot.com. We also have support in Europe at support-eu@tecplot.com. And if you're not in one of those two regions, we do have distributors worldwide. So please contact your distributor first. They're going to be in your time zone, and they're going to be your first line of defense. You can find a list of distributors on the Tecplot 360 website. So if you're not sure who your distributor is or who you should contact for support, go to our website first and look for your region on the map. Okay, it looks like no additional questions have come in. So again, thank you for your time, and look forward to the next webinar. Bye-bye.